Hello and welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you the fourth normal form and the fifth normal form in the normalization process. So in my previous videos, I've already explained all the steps of normalization starting from 1NF to BCNF, and I've also explained decomposition and the process of normalization. So those videos have been linked down below, and I recommend that if you haven't watched those, you watch that before starting to watch this video, where I'm going to explain the last two steps in normalization, which are 4NF and 5NF. So let's begin with 4NF. 4NF of course stands for the fourth normal form, and here the condition is that it should be in BCNF and there should be no multi-valued dependencies. Now we need to understand what a multi-valued dependency is. So let's take a look at this table. Here there are two courses in this table. First of all, there are three columns: course, teacher, and book. And there are two courses being taught, DB and SQL. And the name of the teacher is given. So Abe is teaching DB, Thomas is teaching DB, Ruth is teaching SQL, and Abe is teaching SQL. And then there are some books mentioned. So if you notice, then for DB there are two books, databases and DBMS, which are repeating. And for SQL there are two books, which are Learn SQL and SQL Plus. So this is the table given to you for the 4NF. Now this table does not contain any functional dependency, because a functional dependency would mean if I ask you a question, you should be able to give me one single answer. In this case, let me give you an example. If I ask you, who is teaching DB, can you give me one answer? No, because it's being taught by Abe as well as Thomas. If I ask you, which course is being taught by Abe, then once again, you cannot give me one single answer, right? Although, in this case, you can give me an answer that Abe is teaching DB and SQL, but that's not one answer, because Abe is teaching two different courses, and that's why there is no dependency from teacher to course, or from course to teacher for that matter. And if I ask you which book is Abe is using four different books, you cannot give me one answer there, obviously. So teacher determines book is not a possibility at all. And if I say book determines course, then I might ask you, in that case, which book is being used for DB? And in this case again, you cannot give me an answer, not one single answer. And so once again here, you do not have as such any functional dependency, but you do have a multi-valued dependency, and this is slightly different than a functional dependency, but I'll explain it to you. If you have a teacher Abe and you have a course DB, then Abe is going to refer all the reference books in order to teach DB. So let's say that the course DB has only two reference books, and those are databases and DBMS. Then Abe is obviously going to refer both. So you see, if I ask you the question, which books are being referred by Abe in order to teach DB, now you can give me exactly two answers, which are databases and DBMS. And if I ask you which book is being referred to by Thomas to teach DB, once again you can give me exactly two answers, which is databases and DBMS. If I ask you which books are being referred by Ruth to teach SQL, you can give me two answers, Learn SQL and SQL Plus, which are exactly two. And once again, if I take a combination of SQL with Abe, I will get the same two books, which are Learn SQL and SQL Plus. This type of dependency is called multi-valued dependency, and it is written in this manner. We write course and we put a double arrow and write down book. So this is read as course multi determines book. And once again, of course, there are anomalies caused by this, but I'm not going to go into detail. By now you get the picture of what anomalies are, and you can yourself point them out. There is insert, update, delete anomalies, which are happening here, of course, because the names of teachers and names of courses and books are repeating. So to remedy this, to remove that multi-valued dependency and bring this table into a 4NF, we need to perform something, right? And these anomalies, I am pointing them out, but I'm not going to tell you in detail what these anomalies are all about. I leave it up to you to understand how this causes anomalies. If you don't know what anomalies are, please watch the videos on 1NF, not 1NF, from 2NF to BCNF onwards, and you'll understand what anomalies are. Now, in this case, we are going to divide this table or decompose this table into these two parts. The first part is course and teacher, and the second part is course and book. Now, obviously, the anomaly, the multi-valued dependency is gone because in the absence of the teacher column in this table, I can no longer have a multi-valued dependency. It requires two columns to be present and they are not. So there's no multi-valued dependency, and I have separated it out, and now you can see that a lot of redundancy is gone, like the name of the teacher is not repeating so many times and the name of the book is not repeating so many times. So if I want to add a new teacher, I can directly just go and add the new teacher without knowing which books to refer. And if I want to add a new book for a course, I can do that too without, assigning a teacher to that book. And deleting, also the delete anomaly is also taken care of. I can just delete anything I want from here without affecting anything. For example, if I want to delete the book databases, I can just remove it. And I still have the course DB present in my second table, so there's no problem. And if I want to delete some particular teacher teaching some course, I can do that too without affecting the books being referred. So this now is in 4NF, and that's what 4NF looks like. And now we are going to see the last step of normalization, the last process in normalization, and that is known as 5NF. 5NF stands for the fifth normal form, and for this you have to consider this table. And the condition given for 5NF is that it should be of course in 4NF because that's the step right before this, and there should be no join dependencies. Now these are again a different kind of dependency, and once again I can go ahead and tell you that there is no functional dependency in this table, because as you can see, if I give you also I would like to tell you what this table is about. So it contains three things. One is S hash, which is supplier number, P hash, which is part number, and PR hash, which is project number. This is a table once again taken from an auto parts database. So it's a very small sample of the database. So it tells you which supplier is supplying which part and it's being used for which project. So it's a very simple table, and it serves the purpose of understanding 5NF. So first we need to know that there are no functional dependencies in this table, and even if they are not actually creating any redundancy. So in this case, the relation is already in 4NF because of course there is no multi-valued dependency either. But there's a join dependency, and how do we know that there's a join dependency? You can do it in this manner. So you take the table and divide it into three parts. This is the first part, S hash and P hash. This is my second part, P hash and PR hash. And my third part, which is PR hash and S hash. So take a look at the first part, which is supplier number and part number. Here you can see I have kept only unique values. So S1 and P1 in the original table appears in the first row and in the fourth row. So I'm going to put it only once, of course, in my table. Then the second table, contains part number and project number, and here you'll notice that P1 and J1 appear in third and fourth rows twice, and that's why I'm not going to put them twice, so that's why there are only 3 rows. And project number and supplier number, here too we have something repeating, and that is S1 and J1, which appear in the second row and the fourth row, but we are going to put them only once, and that is why it gives you only 3 rows. So I hope you understood how I've created these 3 parts. There are 3 columns, so I created 3 parts. Now what we are going to do is use the first 2 parts and perform a natural join between those 2. So this is what you get. Now let's understand how this natural join is happening. Natural joins always work based on a common column between 2 tables. So which column is common between the 2 tables on the top? You have P hash and P hash in both the tables. So of course your natural join will be performed on the basis of P hash. So let us see. You have P1 in the first row, which is matching with P1 in the second row, and that is why we are putting the first row as S1 P1 J2. Now once again P1 also matches with the third row, and that's why we are going to put S1 P1 and J1. Next we have S1 and P2. P2 matches with the second row, so we are going to include S1 P2 and J1. And next we have P1, S2 and P2, and S2 and P1, and P1 matches with the first row, so we will include S2, P1 and J2. And it also matches with the third row, so we will include S2, P1 and J1. So this is what my final table looks like. And now what we are going to do is we are going to take a natural join of this resulting table with the third decomposed part of the original table. So you can see now I'm going to take a natural join of this table with my third part of the table, which is project number with supplier number. So now how does the natural join process work? When there's more than one column which is common, then it performs the natural join based on more than one columns, and that is allowed. So you can see here now that there is, in this case, there is supplier number and project number both repeating in both the tables. So we will perform the natural join based on that. So how that works is, in the first table, I have S1 and J2 together in the first row. So I just need to check if in my second table I have the same thing also. Let me just first show you the result of this. So the result of this is this table, and I'm going to remove some rows from there later on. So now S1 and J2 are appearing in the first row, so in the left hand side table, and on the right hand side table S1 and J2 are present. So we are going to keep this row. The second row contains S1 and J1, which are also present in the right hand side table. So once again, we are going to keep this row also. Then we have S1 and J1 appearing again, so obviously that remains 2. Then next we have S2 and J2 in the fourth row, and S2 and J2 combination is not present on the right hand side, and so this is the combination that I will remove from my table. And the last row is S2 with J1, which is present in my right hand side table. So I'm going to keep this. Now this is the table I get. I have 4 rows because I have removed the 4th row. So if you match it with the original table, this is the original table, then you can notice that it's actually the same. All the rows, all the values are matching exactly in the same way as you can see. So this is called a joint dependency. In order to find out a joint dependency, you would have to break the table, you would have to decompose the table, and only then you'll be able to find the joint dependency when you take a natural join and you get the original table back. If this happens, then your table contains a joint dependency, and in order to remove it, you are going to keep those fragments of tables that you already created from the original table. And then your relation would be in 5NF. So that's what the normalization process looks like from 1NF to 5NF. Those are all the steps that you need to apply to perform normalization. And most often, it's enough to do up to 3NF or BCNF. Up to then, your table's quite efficient already. And most of the time, we do not perform 4NF and 5NF in practice and only study them theoretically. So I hope this normalization process is quite clear to you now. And I will be creating more videos for more topics after this. So stay tuned for that, and thank you for watching.